This is Unit 7, Lesson 2, Angles and the Unit Circle. So our lesson essential question is, how can we extend the trigonometric ratios to angles greater than 90 degrees? So at the end of this lesson, we'll be able to understand angles in standard position. All right, example 1, find the measure of an angle in standard position. So what is the measure of the angle shown?
What is the measure of the angle shown? The angle represented by theta is in standard position. The vertex is at the origin, and the initial side of the angle is the positive x-axis. The terminal side is the other ray that forms the angle. You can use a reference triangle to find the angle measurement. Draw a vertical line from the point given to the x-axis to form a right triangle. Give the supplementary angle a name, beta. Now you can use this triangle and trigonometry to find the missing angle. You know two of the sides of your reference triangle. The bottom side is length 4, as the base of the triangle goes from x equals 0 to x equals negative 4. The left side is length 4 times the square root of 3, as the left side of the triangle goes from y equals 0 to y equals 4 times the square root of 3. You are missing the length of the hypotenuse of your triangle, so use the Pythagorean Theorem to find the side length. Substitute in the side lengths of 4 times the square root of 3 and 4. Simplifying, the hypotenuse of the triangle is 8. Examine the lengths of the sides of the right triangle. Recall that in a 30-degree, 60-degree, 90-degree right triangle, the shorter leg is x, the hypotenuse is 2x, and the longer leg is x times the square root of 3. The dimensions fit the pattern of a 30-degree, 60-degree, 90-degree triangle, so beta equals 60 degrees. Since beta is supplementary to theta, we can solve for theta equals 180 degrees minus 60 degrees. Therefore, theta equals 120 degrees. An angle in standard position can have its measure described in different ways. It can be described as a positive angle measure. The angle is between 0 and 360. The angle shown is 120 degrees as a positive angle measure. It can also be described as a negative angle measure. The angle is between negative 360 and 0. The angle shown is negative 240 degrees as a negative angle measure. Lastly, the angle can be written as a positive angle measure greater than 360. Theta plus 360 times k, where k is a natural number representing the number of rotations. With one rotation, this angle is 480 degrees. 2 rotations is 840 degrees, and so on. So this angle is 120 degrees plus 360 times k. In standard position, the measure of the angle could be 120 degrees, negative 240 degrees, or 120 plus 360 times k degrees, where k is the natural number. Since these angles all share the same initial and terminal side, they are coterminal angles.
All right, so let's try it. Given the initial and terminal sides, find a positive angle measure, a negative angle measure, and an angle measure greater than 360 for each angle below. So for A, we can see that from here to here, that's actually 180 degrees. It's a straight line. So for my positive angle, it's 180. My negative angle is negative 180 because 360 minus 180 gives me 180. And then an example of one that's greater than 360, I take 360 and I add it to 180, which would give me 540. Okay. So for B, I have from here to here. Okay, so I know that going here is a straight line, and I know from 3/4 of the way around is 275, because these are each 90 degrees. So what I can do is I can take 270 minus 25 which gives me 245. So my positive is 245. My negative is going to be 360 minus 90 minus 25, which is also. I'm going to take 245, which was my positive, and then subtract it from 360, which gives me negative 115 degrees. And then my angle measure greater than 360. I'm going to take 245 plus 360, which gives me 605. Example 2, find reference angles. So what is the reference angle for a 130-degree angle? When an angle is in standard position, the reference angle is the acute angle formed between the terminal side of the angle and the x-axis. So to find the reference angle for any angle, first sketch the angle by considering the quadrant in which the terminal side lies. So for example, it'll be in quadrant 1 if it's between 0 and 90, or negative 360 and negative 270. In quadrant 2, if it's between 90 and 180, or negative 270 and negative 180. In quadrant 3, if it's between 180 and 270, or between negative 180 and negative 90, or quadrant 4 when it's between 270 and 360, or negative 90 and 0. Notice that quadrant 1 and quadrant 4 are opposites of each other, so positive versus negative. Same with quadrant 2 and quadrant 3. So 130 degrees, so here's 90, but it's less than 180. So 130 degrees in standard position has its terminal side in quadrant 2. The reference angle is 180 minus 130, or 50. When the given angle is greater than 90 degrees and less than 180, it is supplementary to its reference angle. What is the reference angle for a 210-degree angle? First, I'm going to sketch the angle. So 210 is going to end up in my quadrant 3. The measure of the reference angle is 180 less than the measure of the given angle. So 210 minus 180 equals 30. The reference angle is 45 degrees and its terminal side lies in quadrant 4. What are the possible positive measures and negative measures for the angle? So I draw the angle in quadrant 4, 45 degrees below the x-axis. So here it is, 45 degrees below the x-axis. A positive angle measure is 360 minus 45, which gives me 315. So I start here and I go all the way around, I get 315, and my negative angle measure is negative 45. So they gave me the reference angle of 45 degrees and where it was. Okay, and then I solved from there. All right, let's try it. Give a possible positive angle measure and a possible negative angle measure for each reference angle. 10 degrees. A is 10 degrees in quadrant 3. Okay. So quadrant 3. Here's my reference angle of 10 degrees. So I'm going to add 180 plus 10, which would give me 190. So my positive is going to be 190, so 190 degrees. And then my negative angle is going to be 360 minus 190, which is negative 170 degrees. Okay. For B, I have 15 degrees in quadrant 1. So over here in quadrant 1, I'm looking for 15. There's 15 right there. Okay. So I want to find a positive angle and a negative. So this one's actually super easy because it's already in quadrant 1. So my positive is 15. My negative, remember, I'm going to start here and I'm going to go all the way around. So 360 minus 15 is 345. So negative 345 degrees. Concept, the unit circle. The unit circle is a circle that has its center at the origin and has a radius of 1. In any right triangle formed with the radius as the hypotenuse, the length of the hypotenuse is 1. Based on the right triangle trigonometry, sine of theta equals I over 1 or y, and cosine theta equals x over 1 or x. Example 3, find the coordinates of a point on the unit circle. An angle theta has a measure of 60 degrees and a terminal side that intersects the unit circle at x, y. What are the values of x and y? So first I want to sketch a figure to represent the problem. So here's my unit circle. Here's my hypotenuse of 1. Here's my angle theta. Here's x, and here's xy. Okay, so if I bring this down, this would form a triangle. Okay. So this figure represents the unit circle, so the radius is 1. Draw a reference triangle formed by drawing a perpendicular line from the terminal point of an angle theta in standard position. The figure represents the unit circle, so the radius is 1. Draw a reference triangle formed by drawing a perpendicular line from the terminal point of an angle theta in standard position to the x-axis. The hypotenuse of this triangle is 1. Sine of theta equals y over 1, which equals y, and cosine of theta equals x over 1, or x. So the reference triangle formed is a 30, 60, 90 degree triangle. So you can use the relationship between the sides to find the value of x and y. The side across from the 30 degree angle is half of the hypotenuse, or 1/2. The side across from the 60 degree angle is the square root of 3 times the shorter side, or square root of 3 over 2. So sine of 60 degrees equals the square root of 3 over 2, and cosine of 60 equals 1/2. And the coordinate x, y is 1/2 square root of 3 over 2. All right, so let's try it. An angle theta has a measure of 45 degrees and a terminal side that intersects the unit circle at x, y. What are the values of x and y? Okay, so you can draw a circle for this. So here is my triangle. We know that this is a 45, 45, 90 degree triangle. So theta is 45, and this one's also 45. We know my hypotenuse is 1 because this is the unit circle, so it's a radius of 1. Okay, so sine of theta, remember sine is opposite over the hypotenuse. We know that these are both the same. So these sides are both going to be the same length. Okay, so this is going to be my opposite over my hypotenuse. Okay, so x. So what happens here is sine is going to be the square root of 2 over 2, and cosine of x is the square root of 2 over 2. All right, example 4, understand radian measure on the unit circle. So what is the radian measure of an angle? The radian measure of a central angle is equal to the length of the arc of the unit circle subtended by that angle. So this right here. An angle measure of 1 radian subtends an arc on the unit circle with length 1. So the radius of the unit circle is 1, so the circumference of the unit circle is c equals 2 pi r, which equals 2 pi times 1, or 2 pi. This implies that a 360 degree angle, or 1 complete rotation on the circle, measures 2 pi radians. The x and y axis divide the unit circle into 4 congruent arcs, each representing pi over 2 radians. In general, the radian measure theta of an angle is the length of the intercepted arc measured in radian units. So theta equals the length of the intercepted arc over radius. For example, if an angle measures pi over 4 radians, its intercepted arc is also pi over 4 radians. The angle lies in quadrant 1 with the terminal side halfway between 0 and pi over 2. How can you use radians to sketch an angle? Suppose an angle measures 4 pi over 3 radians. Its intercepted arc on the unit circle is also 4 pi over 3 radians. The top half of the circle represents pi. 4 pi over 3 radians is greater than pi radians, but less than 3 pi over 2 radians. Therefore, an angle with a measure of 4 pi over 3 radians lies in quadrant 3 and has a reference angle of pi over 3. All right, let's try it. Sketch the graph of an angle that measures negative 5 pi over 6 in standard position. So we know that 5 pi over 6 is going to be less than pi, right? Because 6 pi over 6 would give me 1 pi. So if I'm going negative, I start at 0 and I'm going this way. Negative 5 pi over 6 is going to be somewhere over here. Okay. So negative 5 pi over 6. Example 5, converting between degrees and radians. How do you convert between degrees and radians? So 1 full rotation of a circle is 360 degrees. It's the same as 2 pi radians. Half of a rotation, or 180 degrees, is the same as pi radians. We also know 90 and 270 because they're half pi over 2, and 3 pi over 2, respectively. So 0 radians, 0 degrees. Pi over 2 radians is 90 degrees. Pi is 180 degrees. 3 pi over 2 is 270, and 2 pi is 360. To find the value of 1 radian in terms of degrees, I solve for 1 radian. So 2 pi radians equals 360. I divide both sides by 2, and then both sides by pi. So 1 radian equals 180 over pi. For example, if an angle measures pi over 2 radians, what is its measure in degrees? To convert any number of radians to degrees, multiply the number of radians by 180 over pi. To find the value of 1 degree in terms of radians, divide both sides by 180. So pi over 2 times 180 over pi, the pi's cancel. 180 divided by 2 gives me 90. Pi radians equals 180 degrees. 1 degree equals pi over 180 radians. So for example, if an angle measures 120 degrees, what is its measure in radians? I take my measure that they gave me and I multiply by pi over 180 radians. When I simplify that, I have 120 over pi, 120 times pi over 180. When I simplify it, I get 2 pi over 3. B, how can you convert each angle measure from radians to degrees or degrees to radians? So I have pi over 7 radians and 75 degrees. So pi over 7, I multiply by 180 over pi, which gives me approximately 25.7 degrees. And 75, I multiply by pi over 180, which gives me approximately 5 pi over 12 radians. Let's try it. Convert the angle measure 112 degrees to radians. So again, I'm going from degrees to radians. So I'm going to take the number that they gave me, 112, and then I'm going to multiply it by pi over 180. So 112, this gives me 28 pi over 45, which is approximately 1.95. Next, I want to do pi over 6 radians to degrees. So from degrees to radians, it's pi over 180. From radians to degrees, flip that. It's 180 over pi. The pi's cancel each other out, so I have 180 over 6. 180 divided by 6 gives me 30 degrees. Example 6, use radians to find arc length. NASA is tracking a satellite traveling in a circular orbit above Earth. It can only be tracked while it orbits through a pi over 6 angle. The radius of Earth is 6,400 kilometers. What is the distance the satellite travels while it is being tracked? So Earth's radius is 6,400 kilometers. The satellite is 320 kilometers above Earth's surface. So the satellite travels through an arc surrounding Earth. So here's my unit circle. Here's my arc, my measure. So pi over 6 radians. The radius of Earth is 6,400 plus an additional 320 kilometers, or 6,720 kilometers, because that's the radius of the Earth plus the distance from the Earth to the satellite. Okay. I use the formula for the radian measure of an arc to find the distance through which the satellite can be tracked. So radian measure equals length of intercepted arc over the radius. So the length of the intercepted arc equals the radian measure times the radius. We know that the radian measure is pi over 6 and the radius is 6,720. So I multiply that number, 6,720 kilometers, by pi over 6. So the satellite can be tracked for about 3,519 kilometers. If the satellite could be tracked for 5,000 kilometers, what angle in radians would it pass through? So again, they gave me the same information for the radius and the kilometers. Instead of giving me the angle, though, they gave me the distance that it could be tracked, so what it equals to. So I have that radian measure equals the length of the intercepted arc over the radius. Okay. We know that the radius was 6,400 plus 320, which is 6,720. And the length of the arc is 5,000. So 5,000 divided by 6,720. 5,000 divided by 6,720 gives me 0.74. So 0.74 radians. All right, concept summary. Angles in the unit circle. So in standard position, an angle is in standard position when its initial side is the positive x-axis and its vertex is at the origin. Vertex at the origin, here's my initial side, here's my terminal side. The reference angle is the acute angle formed by the terminal side and the x-axis. Degrees and radians. So for a unit circle, I have pi over 6, which is 30 degrees, pi over 4, which is 45 degrees, and pi over 3, which is 60 degrees. So from 0 to pi over 2 is 90, pi is 180, 3 pi over 2 is 270. Radians equals pi over 180 times its degrees, and degrees equals 180 over pi times radians. And that is the end of Unit 7, Lesson 2.